as soon as you'll see my screen. Here we go. So this little question here, alright, you'll notice a triangle within a triangle, alright? They love to bring these types of questions, triangle within a triangle. So they say in the diagram above, not drawn to scale, because you know people like to go measuring lines like it will help them. P and Q are midpoints of the sides x, y, and x, z of triangle XYZ. They're saying given that XP is 7.5, XQ is 4.5, and the area of the triangle XPQ is 13.5 cm squared, calculate, first thing, the size of angle PXQ, expressing your answer correct to the nearest degree, and then they want the area of triangle WXZ. Okay. So, let's take some time and dissect this big set of information. So the first thing is, let's look at what they want us to do, right? So they're saying here the size of angle PXQ. So the size of angle PXQ, we're looking at the angle at the apex of this triangle. So this is the triangle, and this is the angle that we want to get the magnitude of. Alright? Let's see what information we're given that could help us with being able to calculate the magnitude of that missing angle. So, they tell us that P and Q are midpoints of the sides of XY and XZ of triangles XYZ, okay. Then they say XP is 7.5 centimeters. XP 7.5 centimeters. So, where should I label 7.5 centimeters? Anybody? Which side of the triangle should I label 7.5 centimeters? Between X and P. Sounds like a no-brainer, but it is important for us to always remember these things, alright? So, once you label your diagram properly with the information that you're given, it helps create a clearer picture of what you're doing. Alright, next piece of information, right? So we have XP is 7.5 centimeters. They then say that XQ is 4.5 centimeters. So where should we label 4.5 centimeters? Lovely. Between the line. So between these 2 points here, XQ is this little line across on the side. So 4.5 cm. Alright, so what I'm actually going to do, I'm going to just redraw the triangle a little bit. Right, so something like this. Struggle is real. Okay, we'll look at that. Okay. So this is X, P, Q. 0.5, 7.5, and theta. Okay. Alright. So 7.5, 4.5, we want to get the magnitude of this angle. I will label as theta. And they said there's another piece of information, right? They said that the area of the triangle XPQ is 13.5 centimeters squared. So the area is 13.5 centimeters squared. Alright. We want to get the angle theta. Any thoughts about what we're going to do here? So I want you to take a look at the information, take a look at the diagram, right? And be very, very careful about it, because this particular type of question is pretty easy to get confused with, alright? So if I want to find the magnitude of the angle, anybody want to tell me what we'll do? Anybody? What do you think you should do here? So remember, we just want to hear thought processes. We're not here to criticize and be like, oh my god, that's so terrible, how dare you think that. Come on, tell me, what are you thinking about? When you look at this question, what do you think you need to do? Okay, so we have a suggestion to find the length of PQ. Okay, alright, so if we find the length of PQ, what do you think that will help us with doing? If we want to get the magnitude of theta. So I like that. She wants to actually utilize cosine rule. That's completely okay to do that, you know. But I just saying it might take a little longer to do that, simply because one, what type of triangle are we dealing with here? Anybody? What type of triangle are we dealing with? There you go, it's a scaling triangle. So we're going to, if we decide that we want to find PQ, we're going to enter a phase of struggles immediately, because it's not a right angle triangle that we could just apply Pythagoras, get PQ. We can't say we're going to use some I don't know, thing to just get PQ, right? So while the intention is good, you could utilize cosine rule if PQ was there. So to save yourself the headache of trying to figure out some kind of ratch to get PQ, here's what I will suggest. Instead of using cosine rule, there's another rule. The sine rule. Y'all remember the sine rule? So sine rule had two different rules. One was dealing with ratios of sides and angles, and then there's the sine rule for area, and that's the one that we're going to use right now. Alright, so the sine rule for area, the reason why I want to use this rule, it's as simple as, one, it relates the area of the shape to an angle given and two sides of the triangle, and whenever we're using sine rule, we actually have to have the included angle, which is in this case theta. So this is the reason why I'm going to use my sine rule here, and the area is given by a half. In this case, if I apply it to my triangle here, it will be a half times the length of xp by the length of xq sine of the included angle theta, right? So I have the length of xp, I have the length of xq, I also have the area. Yes? That's it. So anytime you want to find the area of a scaling triangle, think sine rule, the area rule. Alright? So the area of this triangle, which is 13.5 centimeters squared, is given by a half xp by xq by the sine of the included angle theta. Alright? So what I would encourage you to do now, give it your best attempt, where you substitute your values, and I want somebody to tell me what they get for theta. Alright? So this is testing your ability to substitute correctly, to transpose accurately, and then I want to hear what you all get for theta. So I'm testing your precision, your accuracy, your algebraic skills, everything all in one. Let me hear what you get for theta. So take 2 minutes and work that out for me, and then you're welcome to flood the chat with your magnitudes, or you can unmute and you can tell me, or you can text it to me and tell me. So don't mean to sound like some kind of some kind of call in your thing, texting your answer, whatever. But y'all can use WhatsApp chat and flood the WhatsApp chat. Let me know what's going on. Oh, I'm now seeing this message. technology is sticking on my side now. Alright, so I'm going to go to another slide to do the working, so you'll see me working there exclusively. So I'll just rewrite the information. So the area of my triangle is 13.5 centimeters squared. I want to find theta given that xp is 7.5. And xq is 4.5. So we know that the area by sine rule is a half xp xq sine theta. And like I said, we're substituting our values now, so that's the first thing we should do. Substitute area and lengths. And like I said, I'm testing your ability to transpose, alright? Testing your ability to transpose. So obviously the first thing you should do is simplify as best as you can, alright? So you could either work out what's a half times 7.5 times 4.5. So you get, alright, so I'm just going to put the next line of working. Let's see if anybody got this so far. So you'll have 13.5 is equal to 16 point, that's a terrible 8. Alright, 16.875, which if you round off and you get 16.9, it's just fine. So I see a message in chat. I'm going to check it just now. Alright. And then from here now, I want to make sine theta the subject because I want to be able to get theta. So I will divide both sides by the 16.875. And then from there, I'll be able to get sine theta and then get theta. Alright? So, oh my goodness, I put divided by sine theta. Wonderful. Wonderful. Alright, so I'll get in my next line now. That's where sine theta should be. Sine theta is equal to, what is this wonderful ratio going to work out to be? Let's see. Alright, so let me just take a quick peek at the chat, because it did not pop up on my screen. Just sad. Alright, so Calissa got 53.13 degrees. So just take your answer and round it up to the nearest degree, and you'll have your answer for your first part. So anybody else got the same thing that Calissa said she got? She said she got 53.13 degrees exactly. And if you round it off to the nearest degree as was indicated in question, tell me, did you get 53 degrees? So let's see if we get that. So sine theta is 0.8. So if I want to get theta, I need to do sine inverse of 0.8, and 0.8 theta will work out to be oh, look at that delayed message. Oh my goodness, it just popped up on my phone. Alright, so theta is equal to 53.13 degrees exact to, like, you know, if you want to work it out like that, exact like that. So the answer that we need is theta given in degrees, and you'll get that theta is equal to 53 degrees. Alright, so let's just take a quick poll. How many people were able to get 53 degrees as their answer, or were able to get through some part of the process? I have one hand up so far. Renita has her hand up as well as 2 hands up. So for those of us who were working along, is there anybody who had some challenges along the way and would like some clarification? So raise your hand if you got 53, and in a little bit let's talk about the solution, and you'll let me know if there's anything that you want cleared up. So let me hear you. Carissa, you got through the question? Alright, no problem. Alright, so you were able to get through the process with the substitution and the simplification part. Alright, nice. Ashley, are you with me? Ashley, going once, going twice. Alright, no Ashley. Kanisha, are you there? Have you been managing? Oh, look, Ashley's there. Okay, Ashley's in the chat. Alright, Ashley, were you able to get through the question? So you can type in the chat. So Kanisha, same thing with you. If you're hearing me, you can respond to me in the chat. Were you able to get through the process of doing your substitution, doing your transposition? Did you get the answer? Okay, you know what to do? Alright, that's the important thing, alright? So you just probably need to go back over your process and just check to see where you would have made a mistake. Alright? Jaleese, you hearing me? If you're hearing me, just type in the chat, say yeah. And if you're hearing me, I just checking in with you. You're managing, you got through the question? Alright, so Jaleese says yes, she's hearing me. And you were able to get through the question? You got an answer? Alright, so Ashley says no, but I saw where I made a mistake when the solution was shown. Alright, nice. So that's the important part for me, right? If you're following along and if you're attempting to do it, you're able to see where your mistake is being made so you could just rectify it. Alright? So that's my first 1, 2, 3, 4. Alright, so I called 4 random names today. No, I didn't get the answer, but I'm following. Alright, fair enough. Okay,